Friends, very good morning to everyone. Let us deal with the reactions of phenols. As phenol contains OH group and phenyl group, it can give the reactions of both OH group and the phenyl group. As there is OH group, it can donate H plus, it can act as an acid. OH can react with the COOH, an acid. It can form ester. It can form ethers. At the same time, it can undergo electrophilic aromatic substitution, which includes nitration, sulfonation, halogenation, Frederick's alkylation, and acylation, which is shown by the benzene ring system. Other than this five, it can also show other type of substitution reactions, that is nitrosation, coupling with diazonium salt, Kolbe's condensation, and Riemer-Tiemann reaction. Right? Why? Because this is an activated ring system. Let us look how it can act as an acid. ROH can donate the H plus to H2O and it becomes RO minus. AROH can donate the electrons hydrogen to water and gives us ARO minus. This excess electrons on the oxygen is distributed along the phenyl ring system. This electrons moves over here, it forms the double bond and it has to maintain its tetravalency. These electrons are kicked off to the next carbon. This becomes electron rich. Again, this is unstable. These electrons form the bond. The pi electrons over here moves towards the next carbon to give electron rich center over here. And the process continues and the excess electrons are distributed over the phenyl ring system. As it is electron rich, it is unstable. It is something like when we have more money, we become more unstable. Why we are more unstable when we have more money? Because we have a fear that IT people may come and attack us at any time. That's what to do in that situation. Excess money, whatever you have, you distribute in the system so that you are stable. Money should be generated and should be distributed. That's why we become more stable, like that of phenoxide ion. If there is an electron withdrawing group on this benzene ring system, the excess electron in the phenoxide ion is taken away by that electrons, as it is an electron withdrawing group. Thus, it becomes more stable. More the stability of the phenoxide ion, more is the acidity strength. Electron withdrawing group increases this acidity of the phenols. If there is an electron donating group, already phenyl is electron rich. O minus is donating its electrons. Electron donating group again donates electrons. It becomes much more electron rich. Then it becomes much unstable. That's why it decreases the acidity. Phenols can react with acid. If I take a propanoic acid over here, I'll get corresponding propenyl ester derivative. Salicylic acid with acetic anhydride, I will get corresponding aspirin. This is the ester formation which is shown by alcohols. The similar way, phenols also reacts with acids to give esters. Like alcohols, phenols in the form of sodium salt, that is sodium phenoxide, can react with alkyl halide to give rise to corresponding ethers and sodium halide. This is the reaction given by the alkoxide ions of the alcohol. These are the three reactions which are shown by alcohols are shown by phenols. The electrophilic aromatic substitution reaction occurs. OH is an electron donating group. As it donates electrons, it is a powerful activating group. And as we know that Powerful activating group always directs the incoming group towards ortho and para position. That's why it is ortho para direct. If I take nitration, phenol, I treat with concentrated nitric acid. It is so reactive that all the ortho and para position gets blocked. I will get 2,4,6 trinitrophenol. Polynitration occurs. If in case of toluene, what will I get? I'll get orthohydroxytoluene and parahydroxytoluene. But here we get 2,4,6 trinitrophenol because OH is a powerful activating group. In case of toluene, the methyl group is weakly activating group. How to get orthonitro and paranitrophenol? Instead of using concentrated nitric acid, use dilute nitric acid. You will get mixture of orthonitrophenol and paranitrophenol. It can undergo halogenation when it is treated with aqueous bromine to give rise to again 2,4,6 tribromophenol. As this is a very strongly activated system, it requires no catalyst. It can also undergo the reaction by using a polar solvent and polyhalogenation occurs. It is something like I am rich and my wife is also rich who can support me. I'll become more active. I can do n number of things. Money makes many things. I don't want polyhalogenation means what should I do? I replace water with non-polar solvent carbon tetrachloride and treat with bromine. I'll get orthobromophenol and parabromophenol. I am reducing the reactivity by using a non-polar solvent. In case of nitration, I reduce the reactivity by using dilute nitric acid instead of concentrated nitric acid. This is how we can achieve ortho and para derivatives, the required compounds. If I take phenol and treat with sulfuric acid at 15 to 20 degrees centigrade, I'll get orthosulfonic acid derivative. If I heat it at 100 degrees centigrade with sulfuric acid, I'll get corresponding parasulfonic acid derivative. At lower temperature, it is rate controlled reaction. At higher temperature, it is kinetic controlled reaction. If I heat orthosulfonic acid derivative of phenol at 100 degrees centigrade, orthosulfonic acid derivative gets converted to parasulfonic acid derivative. This is the beauty of this reaction. Friedel-Crafts alkylation can also occur. I treat with alkyl halide. Here tertiary butyl chloride. In the presence of catalyst AlCl3, I'll get para tertiary butyl phenol. Ortho is not possible because if the tertiary butyl group is attached to ortho, there is steric hindrance. Hence, preferably it gives para derivative. Friedel-Crafts acylation. If I treat with acid chloride, here butanoyl chloride I taken, in the presence of AlCl3, I will get corresponding para-acyl derivative. However, the same reaction if I do in the absence of AlCl3, it's the OH, it reacts with carbonyl carbon of the acid chloride and gives rise to ester. It is said that ester is formed first and when you treat with AlCl3, it gives rise to corresponding acyl derivatives of phenol. This is because of the fact that it undergoes rearrangement. And this rearrangement it undergoes is shown by Fries and that's why it is named after him as Fries rearrangement. Let us look how this Fries rearrangement occurs. the ester of phenol. When I treat with AlCl3, the aluminum is the positive center as it is flanked with 3 electronegative groups, that is chlorine. Oxygen has lone pair of electrons that attacks on aluminum. This lone pair of electrons in the oxygen is shared with aluminum. Once this is shared with aluminum, what happens to oxygen here? This becomes electron deficient. Right? To satisfy this positive center, the electrons, carbon and oxygen bond breaks and this electrons moves over here and making this carbon positive. To satisfy this positive center, lone pair of electrons here combines with this carbon and it gives rise to corresponding RC triple bond O plus. These two reacts now. The lone pair of electrons over here moves towards the carbon, double bond is formed. It has to maintain its state of valency. Pi electrons moves on to the next carbon. This becomes electron rich. A carbon ion is generated. And this is the carbocation. This is cation, this is anion. Unlike poles attract each other. This excess electrons on this carbon is shared with the positive center of the RC triple bond O. What I am going to get? Corresponding COR, ortho-acyl derivative. As the electrons over here is shared with the carbon, this has become deficient. To satisfy this positive, this electrons moves and this electrons moves, H plus moves away and gives rise to corresponding aromatic compound. This upon hydrolysis, it gives rise to phenolic compound, ortho-acyl phenyl. I'll get. How the para derivative is formed? The lone pair of electrons can move over here, it forms double bond. Instead of this bond on this carbon, it instead of moving onto carbon, it moves to next position and this carbon become electron deficient. Again these electrons moves and the carbon ion is generated at the para position. The para position carbon ion can react with RC triple bond O and it can give rise to corresponding acyl derivative. These electrons can move, carbon hydrogen bond breaks. It has to maintain its state valency. Pi electrons get kicked off to next position and this has to maintain its valency and the carbon kicks off these electrons to this electron deficient oxygen and the positive center on the oxygen is satisfied. Hydrolyze this, I'll get corresponding para-acyl derivative along with AlCl3 and water. This is how the rearrangement occurs and gives rise to corresponding phenylacyl derivative. Thank you. In the next class, we'll be dealing with the remaining reactions.